Let's now explore the rules for a primary key. Primary key can be of one or more columns. So here is an example showing you how to create a primary key with multiple columns. ID and name form the composite primary key here. Whereas if you look at the first slide, you'll see that primary key phrase was mentioned inline. You can either create it inline or separately when the primary key is made up of just one column. If it's more than one column, that is a composite primary key, then this is the format that you should follow. As one might expect, if an insert or update statement attempts to modify the table so that the rows eventually end up having identical primary key values, then that's a constraint violation. Let's see what that means. Here's an in-memory version of SQLite 3 running on the terminal. A table called dummy with just one column called field. It's a text and it's marked as primary key. So now we are inserting into the table with the column and the value is SAM1. At this point there will not be any primary key violations because this is just the first row that's being inserted, so it'll go through. Let's perform the same insert again to observe a primary key violation. As you can see here, the unique constraint failed, dummy.field. That's the demo that shows how to insert two rows to violate a primary key constraint. Turns out there is also another way to do this. So let's just say that we insert a new row called SAM2. And now let's run an update statement. Update dummy, set field equals SAM1, where field equals SAM2. This is also going to lead to a constraint violation because there is already a row with field value SAM1. So that's how you end up making primary key violations either through insert or through update. Let's now knock off rest of the rules. The SQLite allows nulls in primary columns. This is definitely a bouncer for those of you who have used other relational database engines like MySQL or PostgreSQL or even Oracle. It's by design that they allow nulls. What's more surprising is in SQLite world, nulls are considered distinct from other nulls. So you'll not only be able to insert one corrupt row in case you are strictly following your database design, you'll be able to insert a lot of junk data into your system. So that's the reason why in most of the table definitions that we'll see, there'll always be this check not null to enforce that you're not caught by surprise. Let's see a demo on the null constraints. We have a table here called scores with name and score fields, columns, and the name is a primary key. So here's a first row to get inserted. This went through because it's the very first row. Now as you might guess, the next insertion will fail with a constraint violation. Now let's do something interesting. The name, let's make it null and insert a score of 890 to distinguish it from the previous record. As you can see from this insert actually went through. To confirm that the row actually exists, let's do this and you'll see that the blank before the pipe indicates a null in the SQLite 3 shell and the name and the scores are printed. Let's insert one more dummy row. See now that both the rows are inserted and the nulls are actually considered to be distinct from one another. We wouldn't have had this add these dummy rows if we had specified not null in the primary key column. That's the end of this demo for primary key nulls. The last rule here is the primary key phrase is optional in the case of ordinary tables, but it's required for without row ID tables. As you might recall from this very first diagram, you can also declare a phrase without row ID inside this table creation construct. We're going to explore that next, but what's important to notice here is that you need not specify a primary key column for every table.